Top brush is designed to take place of a emitter and thoroughly wash the top of the vehicle. The position you see it in right now is in the rest position, which is up and retracted out of the way, so that if we have a drive-through vehicle, there's nothing in the way for the car to hit. It'll go right through and not be damaged. The programming is designed such that we lower the brush about 6 feet in front of the car to let it come down, be ready to wash the car, to get in the wash position, ready to hit the car as it comes into it. There's a few adjustments that we have to make on the brush when we set it up. We have to set the rotation of the brush. We need to set the RPMs of the brush. And then we also need to set the counterweight so we have the right kind of penetration on the vehicle itself. Also, there are three grease fittings that are rotational, and then 2 grease points that are just pivotal. So the rotational, again, will be every week, and the pivotal will be monthly. The top brush retract is done again with a 4-way max solenoid valve. Although we're only using 1 port on the exit side, we're only using the controlled flow. It's free flowed to the retract position. When the brush is energized, all we're doing is exhausting the air through a nozzle that slows the airflow down and allows the brush to come down nice and smooth and controlled, getting ready to wash the vehicle. And then when the wash service is done, we have a look back function on the computer. If there's another car in the electric eye, then the brush will stay down here in the wash position. If there is not a car there, the cylinder will release, be energized, and the brush will retract and be out of the way until another car is ready to come in at it. The air pressure setting on here is only 1 air pressure setting, and depending on the counterweight and the cloth fill, it's approximately 40 to 50 pounds to retract that brush. When it's energized, as you can see here, the pressure is relieved from the unit, so there is no air pressure holding the brush down against the car. It's all done by gravity and counterbalance. And then when it's de-energized, it pops back up again. The rotation of the top brush is, as you're looking at it from the driver's side, is counterclockwise, and that's the proper rotation. Top of the brush should always be running towards the exit of the car wash. So top of the brush towards the exit, from this side counterclockwise. From the passenger side, it would be a clockwise rotation. But to view it always from the driver's side, it would be a counterclockwise rotation. And then again, we look at the RPMs of the brush. And then we'd like to set the RPMs on the top brush using the flow control and the power pack to approximately 85 to 90 RPMs. So by moving it up a little bit, we've increased the speed. Now if we follow the line on the hub and we use a stopwatch, and we're going to count revolutions per 10 seconds and then multiply times 6. So we press the start button, 1, 2, 13, 14, 15. And 15 there was right about exactly 10 seconds. So we're running about 90 RPMs, which is a good speed for the brush. It's right where we want it to be. And with the brush spinning, it's not returning down, it's not coming down fast enough. So we're going to need to adjust the counterweight to make the brush a little bit heavier so it'll come down home fast enough, okay? So to do that, we're going to shut off the hydraulics and lock out our safety on our motor control center. And then we'll get a couple of 3/4 inch wrenches and we will adjust the take-up assembly on this top brush. To adjust the counterweight, we've got to loosen the 2 bolts that are on top of the counterweight that sit on top of the take-up frame. And then before we do that, we want to make a mark as to where we were sitting previous to the movement. So we loosen up the 2 bolts here, okay? Then we come back here and we've got this marked as far as where it is. We're going to take this ratchet and we're just going to move the counterweight assembly. And we're going to go about 1/2 inch at a time. So with a tape measure to keep both sides even, we're going to measure just about 4, this is 4.5, we'll make it 4.5 inches. So measure from the frame to the end of the take-up assembly. We're set right now at 4.5 inches. We were at 4. And we'll tighten this one up again for safety. And we'll come over here, we'll do the same thing on the other side. So Again, we'll mark where we were. Check our tape, and we're right now at 4 inches to the end. So we'll loosen up our top 2 bolts. But you don't need to be loosened much. Come back here on our take-up assembly. We'll run this take-up nut so our counterweight is moved about 1/2 inch again. Measure it. It's right at 4.5 inches. Go back up here and tighten up our two lockdown bolts. And we'll be ready to give this another test and see how quickly she returns home. Now with the brush spinning, because that's the way it'll be operating when a car comes, we want to make sure that it'll come down in time, come down all the way. So with that 1/2 inch adjustment, we've got the brush down here in a start position. And we want to make sure that the weight of our brush is even. Not heavy, not light, easy enough to go all the way up, and then float all the way down. What we'll do is, the slower the chain speed, the lighter the brush should be. The faster the chain speed, the heavier the brush needs to be. So, not that we need to change it on every time we adjust our speed, but if we run from 60 cars an hour up to 120 or 140 cars an hour, that's double our speed. We'll need to go up and make an adjustment to that counterweight to make it act smooth and be very sensitive and have the right penetration on the vehicle the whole time through. But this is, right now, seems to be pretty light. It's about maybe 7 pounds to lift it, and it stays the same all the way up and all the way down. The top brush, because we use Neoglide as its material, it needs to be lubricated. Doesn't matter whether it's mounted at the beginning of the car wash or at the end of the car wash. The Neoglide material, being a foam base, needs to have lubrication on it. So it comes supplied with a dosatron pump station, so that we can apply both water and soap, or a little bit of wax or detergent, whatever, depending on the position in the tunnel. It's water feed controlled by the computer through the dosatron, draws in the soap to the desired dilution ratio, and then pumped up to the top brush unit where we have 3 nozzles with aerating nozzles to try to aerate and show a little bit of foam or soap on the unit itself. The 3 nozzles that you see up here on the unit are aerated nozzles. They draw air in as they spray the chemical out, so without the use of an air pump or another air solenoid valve, they help to aerate and foam the detergent a little bit. And that's just enough to keep that cloth wet and slippery enough so it'll clean without causing any damage, without grabbing wipers or antennas or any kind of molding or trim. When setting up a dosatron pump, it's important to press the top valve here to bleed any air out of that system. Once the air is out, down here we loosen up the locking ring, and we have a scale on the dosatron pump. This one here is set at 200:1, and quite simply, if we wanted a stronger dilution, we would turn this clockwise and go up to about 190:1. Or if we want to go a weaker dilution, we can go to 256:1 or 240:1. Right now, this one's set by the chemical supplier. This chemical, they recommend just about 200:1, so that's where we're going to set it. We're going to lock that in place so it'll stay, and that's where we're set. The cloth fill on the top brush, to make it very friendly and light on the vehicle, the 2 middle sections here at 8 inches are both full density. They're in every slot. The next 8 on either side are half density, so we were in every other slot. And then the 2 outside sections, a 10 and the 10, are set up at 1/4 density, so they're in every 4th slot. And we count the bolt hole here as a slot. So we're 1, 2, 3 in between every one of them. And what it does, it gives us full density to keep it off the car in the middle. It keeps us lighter at the antennas, lighter at the wipers, and easy on the mirrors as well. And that's the way the density, that's the way the cloth lays out. The little plastic spacers here are designed just to help keep the cloth from sliding out. This is a lock-on. And then again, we have to go through the grease fittings. We've got bearings on either side of the shaft, one on this side here, and then we have two on the opposite end right by the hydraulic motor. All three of these bearings need to be greased on a weekly basis because they rotate 360 degrees. The other two bearings we'll go up and show you was on the top pivot point. It's all UHMW, but we've got a steel plate with a grease fitting to get on and grease that shaft as well. The whole idea is to keep that top bearing should last 5 to 10 years without having to go back up and change it, because the counterweight does weigh about 500 pounds. So we're trying to eliminate having to take that down and put it up again. Grease fittings on the brush again, the three 360-degree rotational bearings on either end of the shaft need to be greased weekly. Again, 2 to 3 pumps is all we need. Keep the moisture out of the bearing, keep the bearing lubricated. And that'll take care of the brush shaft itself. And always important to wipe the grease fittings clean after you've greased, so that we don't have any grease drops or stains on the vehicles as they travel. Through the wash. Okay. 2 pivot points on top are the big UHMW blocks with the grease fitting up on the stainless steel. A couple of shots of grease just to get down into the bearing. Again, wiping off the grease fitting and any excess grease that comes out so we don't drip on the vehicle. Again, as a pivotal bearing, only needs to be greased once a month. There's one on each side of the brush assembly. Okay, grease them and wipe them. And ready for service.